Welcome to question 1 of the 2019 Mathematical Methods Exam 1 for the Northern Hemisphere. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. For part A of question 1 we have let y equal 2e to the power of 2x subtract 1, all divided by e to the power of x, and we are asked to find the derivative to y dx. So firstly we can notice that this is a function divided by another function, so we can use the quotient rule. So to apply the quotient rule, we let the top line of the fraction, the numerator, equal u. So u is going to equal 2e to the power of 2x subtract 1, and v is going to be the bottom line of the fraction, or the denominator, which in this case v is going to just equal e to the power of x. Then we want to calculate du dx, so the derivative of u with respect to x, and looking at our formula sheet this would become 4e to the power of 2x, because we multiply by the coefficient of x, so that becomes 2 times 2 is 4e to the power of 2x, and the negative 1 is a constant, so when it's derived it's 0, so that's the derivative du dx, and then dv dx for e to the power of x just derives to e to the power of x. From the formula sheet we know the derivative d dx of a function u divided by v, which is what we're dealing with, is simply equal to v times du dx minus u times dv dx, and then all of that is divided by v squared. So therefore dy dx, which is what we're asked to calculate for this question, is going to equal the function v, so v is e to the power of x multiplied by du dx, which is 4e to the power of 2x, and then we minus away from that u, which is 2e to the power of 2x subtract 1, and it's really important to have brackets at that point, and that's going to multiply by dv dx, which is just e to the power of x. And then we need to remember that all of that needs to be divided by e to the power of x, v term, squared. So that is the answer, that's the derivative to y dx. However, for this question a little bit of simplification can be done, and you should do that with caution. You don't want to make a mistake after you've got that answer, but you could show by cancelling common factors on the denominator and numerator, and by collecting like terms, that this can actually be written as 2e to the power of 2x plus 1 divided by e to the power of x. So that could be our answer that we would give for part A of this question. So you'll see from the examiner's report they only give you a short answer to this question, and it just says that some students used a combination of the product and chain rules to do this question. You'll also see that they've got a slightly alternative working that I'm just highlighting here in the purple box. What they actually did is they simplified the fraction before calculating the derivative. So in the previous slide we saw that y was equal to, and it was 2e to the power of 2x subtract 1, all divided by e to the power of x. And then the examiners noted that you could turn this into 2e to the power of 2x divided by e to the power of x, and then minus 1 divided by e to the power of x, and that could be simplified to just being 2e to the power of x, that's the first fraction simplified, minus e to the power of negative x. So if we have e to the power of x in the denominator, we can move it up into the numerator as doing e with a negative power of x. So therefore dy dx, which is what this question wanted, could be found by just differentiating each of those two terms separately. So 2e to the power of x will still be 2e to the power of x when differentiated, and negative e to the negative x, we'd take the negative 1 down, which is the coefficient of x, and multiply it by the negative 1 that's already multiplying this term, so you'd get plus e to the power of negative x, and that would be an alternative correct way of answering this question. For part B, we have let f of x equal x squared times cos of 3x, and we're asked to find f dash, the derivative, when x is pi on 3. So for this question we recognise two functions multiplied together, which means we can use the product rule. So applying the product rule, we need to let u equal x squared, so that's the first function that's being multiplied here, and that means v is the second function being multiplied, which is cos of 3x. And then similar to what we did with the quotient rule, we need to calculate du dx, so that is equal to 2x, and dv dx, which is equal to negative 3 sine of 3x, and you can use your formula sheet to help find those derivatives. And then we recall that the product rule says that the derivative d dx of a function u multiplied by a function v is simply equal to u times dv dx plus v times du dx. Or we can just multiply u times dv dx, so those two things together, and then multiply those two things together, which is v times du dx. So when we do that, we find that f dashed of x is going to equal the function u, which is x squared, times dv dx, which is minus 3 sine of 3x. And then we add on to that the function v, which is cos of 3x, and then that is going to be multiplied by du dx, which is simply 2x. Next, we need to substitute in for x the value of pi on 3. So that's going to equal pi on 3 all squared, and then that's going to be multiplied by minus 3 sine, and this becomes 3 times pi on 3, which is 3 pi on 3, or simply pi. And then we add on to that cos of, and this will be 3 times pi on 3, which gives 3 pi on 3, times 2 times x, which is pi on 3. And now we just need to simplify this down, so pi on 3 squared is pi squared on 9, and then we're going to multiply that by minus 3 times, and sine of 3 pi on 3 is the same as sine of pi, and sine of pi we know has an exact value of 0. So that means we multiply this by 0, which means pi squared on 9 times negative 3 times 0 is simply 0, and then we have plus, and cos of 3 pi on 3 is the same as cos of pi, and it has an exact value of negative 1. So we'll be adding on negative 1 times 2 times pi on 3. And when we evaluate that, we simply have negative 2 times pi on 3, which is negative 2 pi on 3. So that is the answer to part B of this question. From the examiner's report, we can see that that is the correct answer that we were looking for.